Decades in the making, quantum computing is the technology that could make today's fastest supercomputer look like an abacus. Teams around the world are racing to build machines using different approaches. While the technology is moving quickly toward reality, it's still too soon to tell when it will get there. This is your Bloomberg Quick Take on quantum computing. The computer you're using now processes information in bits that can represent two possible states, 1 or 0. Quantum computers use quantum bits, or qubits, which can represent 1 or 0, or both at the same time. This is called superposition. Qubits can also exhibit what's called entanglement, a state in which a change to one changes the state of another. These two properties let quantum computers consider multiple possibilities at once, while a normal computer plugs away at one possible answer at a time.
So if we actually figure out how to do these kinds of calculations, we can suddenly solve absolutely complex and just sort of unfathomably long calculations with a quantum computer that would take a traditional computer, no matter how good it is, no matter how fast it is, thousands of years potentially.
There's a lot of hype around quantum computers, and researchers continue to make incremental advances. Evangelists promise machines that can break the most impenetrable coded messages, more accurately predict weather patterns, and instantly diagnose and treat disease based on a specific patient's body. But there's still a ways to go.
It's very difficult to actually make the physical computers, the hardware for these kinds of things. So a lot of the research is sort of in material science, figuring out what's the best hardware to use. And there's a few different options. When you talk about a quantum computer, you don't just talk about, the traditional silicon chips that we see in normal computers.
Manufacturers either use tiny loops of superconducting wire, semiconductors, combinations of both, or even stranger approaches, like twisting subatomic particles into a braid. And many qubits can only exist under temperatures colder than deep space. A Canadian company called D-Wave Systems became the first to sell quantum computers in 2011, although their usefulness is limited to certain kinds of math problems. IBM, Google, Intel, and Rigetti, a startup in Berkeley, have all built working quantum computers. Microsoft is investing heavily, while China is throwing hundreds of millions of dollars into the technology.
Anyone who sort of knows the promise of the technology can't help but get excited about it, and even if it's many, many years away, and even if it never actually works out the way that theoretically it could, this is still something that people think is worth spending a lot of money on.